Hi everyone, welcome back. So in this video, I'm going to continue my lecture series on number theory. Today, I'm going to cover about prime numbers, Fermat's little theorem, and also Euler's theorem. We are going to solve some problems on both Fermat's and Euler's theorem as well. So let's get going. Let's start our discussion about prime numbers. You might have known what a prime number is and what importance does a prime number have. So a natural number n, which is greater than 1, is said to be a prime number if it is divisible only by 1 and by itself. In other words, an integer p greater than 1 is a prime number if and only if its only divisors are 1 and p. So prime numbers play a very critical role in number theory and also cryptography. To just tell you a few examples, the first few prime numbers that we came across are 2, 3, 5, 7, and 11. Every integer greater than 1 is either a prime number or is a product of prime numbers, which we call it as a composite number. Okay, so any number has to be a prime or a composite. Now, one thing very important for our discussion is any integer which is greater than 1 can be factored in a unique way as a is equal to p1, p2, so on till p. This p1 are your prime factors. These are your prime numbers, and any integer can be written in this format. We'll see many examples where we come across this particular way of representing a number. You can see now where p1, p2, pt are the prime numbers, and there are a1, a2 are the powers, which is a positive integer. Now let me take 12. 12 can be written as 2 square into 3 because 12, if you divide it, it is 3 into 4. 4 can be written as 2 into 2. So 2 square into 3. Similarly, 91. 91 can be written as a product of two prime numbers, 7 into 13. Similarly, 3600 can be written like this. So any number can be written as a product of prime numbers raised to the powers. So 2 power 4 into 3 square into 5 square. All these are prime numbers, isn't it? So we have to understand that if p is the set of all prime numbers, then any positive integer a can be written uniquely in the following form. A is equal to p belongs to p to the power of ap, where each ap is greater than or equal to 0. So the powers will either be 0 or greater than 0. Okay, so this is how you can write any integer in the form of prime factors. Let's start our discussion about Fermat's theorem. He is Sir Pierre de Fermat, which I got this picture from Wikipedia. So Fermat's theorem, which is also well known as Fermat's little theorem and Fermat's primality test in number theory, is the statement first given in 1640 by French mathematician Pierre de Fermat, and states that if p is prime and a is a positive integer not divisible by p, then a power p minus 1 is congruent to 1 mod p. So what does this state? What do you understand from this particular theorem? Now let us for example, let's take a is equal to 7 and p is equal to 19. You have to check. You have to say that p is a prime number, isn't it? P is a prime number and a is a positive integer which is not divisible by p. Same. And then a and p are relatively prime, and 7 power 19 minus 1, which is 7 power 18, which is congruent to 1 mod 19. This, what we can do is, you can break this down as 7 power 18, which can be written as 7 square, so on. Now let me first start with taking 7 square. So 7 square is how much? 49. So 49 mod 19 is equal to how much? 19 2s are 38, which gives me a remainder of 11. So what is 7 power 4? 7 power 4 is equal to 11 into 11, which is 121 mod 19. So 19 6s are 114, which gives me 7. So similarly, 7 power 8 can be written as 7 power 4 into 7 power 4, which is 7 into 7, which once again gives me 49, which is equal to 11. And 7 power 16 can be written as 7 power 8 into 7 power 8, 11 into 11, which is 121, which is nothing but 7. So here what I can do is 7 square into 7 power 16. 7 power 16 mod 19 is 7, isn't it? So what I will get is 7 square is 49. 49 mod 19 is 11. So 11 into 7 gives me 77. So what is 77 mod 19? 19 4s are 76, which is equal to 1. So here in this way I can prove Fermat's theorem. 7 power 18 is congruent to 1 mod 19. This is what Fermat theorem tells you. If there are two positive integers, and both of them are not divisible, they are relatively prime to one another, then in that case a power p minus 1 is congruent to 1 mod p. Now there are many problems that can be solved using Fermat's little theorem. So let me solve a few things. It says that 7 power calculate the following using the using the Fermat's theorem. Okay, fine. Let me take this and 7 power 2019 mod 13. Now, if you see 7 and 13, you can see that's A and P. So they both are relatively prime. So in that case, what I can do is 7 power 12 is congruent to 1 mod 13. I know that from Fermat's theorem. So how do I express 2019 in 12s? If I use my multiplication, I can write down that 7 power 12 to the power of 168 gives me 2016, isn't it? So into, I can write down that 2016 means 7 cube. So this all equals to 1 in mod 13. So what is 7 cube? 7 cube is nothing but 343 mod 13, which if you calculate, you will get 5 as the answer. So this is how you calculate it. Similarly, once again, you check here, 4 and 11 are relatively prime or not. If they are relatively prime, I can say 4 power 10 is congruent to 1 mod 11 using Fermat's theorem, because 11 minus 1, 4 power 11 minus 1 is 4 power 10 and is equal to 1. Now, if I can write this down in a format, 4 power 10 to the power of 53 into 4 square. Isn't it? I can write this in this manner, 530 plus 2, which gives me 532, which equals to, this all is equal to 1 and 16 mod 11. Once again, I get the answer as 5. And if you take larger numbers also, it's the same way, how you divide it. So 22 and 2, are they both, sorry, this is mod 11, my mistake. This is mod 11. 22, you cannot apply 2 and 22. Now, because the GCD is more than 1. So 2 power 10,000, 2 not 3 mod 11. What is this? So 2 and 11, if they're relatively prime, I can say that 2 power 10 is congruent to 1 mod 11. In that case, what I can do here is 2 power 10 to the power of 102 into 2 cube. This is 10 into 1020, 2 cube. And here I can write it down as 2 cube mod 11 is 8. So the answer will be 8. Okay. So next, here comes, this is what we said, and 1020. How do you do this? 2 power 20 plus 3 power 30 plus 4 power 40 plus 5 power 50 plus 6 power 60 mod 7. How do you do this calculation? Once again, you please check whether these numbers are relatively prime to 7 or not. That means they don't have any other multiple in common. In that case, I can simply break it down as, what is mod 7 means 2, 6. So 2 power 6 into 3 into 2 square plus 3 power 6 to the power of 5 plus 4 power 6, 6 are 36 into 4 power 4 plus 5 power 6 into 8 into 5 square plus 6 power 6 whole to the power of 10. We can write this in this particular manner, isn't it? Why did I write like this? Because I know mod 7, a power p minus 1. So 2 power 7 minus 1 is always congruent to 1. So this equation will become 4. This is 1. 3 power 6 is 1. 1 power 5 is 1 plus 1 plus 4 power 6 is 1. So 1 power 6 into 4 power 4 is how much? 4 4s are 16, 16 4s are 64. And this, when you do it with mod 7, you get an answer as 4 plus 5 square is 25. So 25 mod 7 is 4 plus, once again, this is 1. 1 power 10 is 1. So you get a total as 5, 9, 14 plus 1. You can see this 14, isn't it? Which gives me 0, because 14 mod 7 is 0, isn't it? The remainder. This is my answer. There are other problems also. Use Fermat's theorem to find a number A between 0 and 92 with congruent to 7 power 1013 modulo 93. So for the first problem, what I need to do is A is equal to or congruent to, I need to find a number A which is congruent to 7 power 1013 modulo 93, isn't it? So this is what I need to find out. So how do I find out? If I check for 7 and 93, I know that both are relatively prime. So I can understand, I can write down that 7 power 92 mod 7 power 92 is congruent to 1 mod 93. Then if I divide 1013, what I will get is 7 power 92 into 11, that is 4 plus 1 into r into 7. So this is how I get 7 power 1. This is 1012 into 7. So which gives me, which I can write it down as 7 power 92 whole power 11 into 7 is nothing but 7 mod 93. So the x value is 7, which is congruent to 71013 model 93. That means I found the remainder. Similarly, for the second problem, if you take it down, it is asking using Fermat's theorem, find a number x between 0 and 37, which with x power 73 congruent to 4 modulo 37. So it is asking me x power 73 is congruent to 4 mod 37. Now I have to find x here, isn't it? So how do I write? I need to find out that x should be relatively prime, isn't it? So x power, if x is relatively prime, I can say x power 36 is congruent to 1 mod 37. In that case, I can write x power 73 as x power 36 whole square into x. Now, if I implement this whole thing here, I can write down x is equal to 4 mod 37. Why, sir? Why did you get x here? Because x power 36, I already know it is 1. So 1 into x gives me x. So the answer for the number x is 4, which is congruent, isn't it? Hopefully you understood how did I get this. By identifying that this is relatively prime, I can write this down, and then when I broke it down, I directly got the x value. So let me take the third problem. Using Fermat's theorem to find a number x between 0 and 36, once again it is asking me to find out that x power 109 is congruent to 8 mod 37. Now once again you have to assume that x is relatively prime to 37, and which implies x power 36 is congruent to 1 mod 37. So how it all comes down to how do you write the 109? So 109 can be written as 3 into 36, isn't it? Plus 1, which makes my thing as x power 36 whole cube into x is congruent to 8 mod 37, which implies this all goes to 1 and x is equal to 8. This is my answer. All these problems are all simple if you understand how to implement the theorem. That's all. Now if you take the fourth one, solve the congruence. X power 103 is congruent to 4 mod 11. Once again, it's very simple. If you take down x power, if you consider that x power 10 is congruent to 1 mod 11, then you can write it down as x power 10 to the power of 10 into x cube is congruent to 4 mod 11. Now this becomes 1. Here, once I get this equation as x cube is equal to, or mod is congruent to 4 mod 11, I have to start using trial and error method to, because it's mod 11, all the values I will be having is 1 to 10. If I start implementing 1, 2, 3, then I have to get the answer. If you see 2 cube is 8, not possible. 3 cube, 3 is 9, 27. 27 mod 11 is how much? 5. It's not possible. 4 power, 5 power. In that case, when you see, you get 5 cube. 125 mod 11 is 4. 125 mod 11 is 4, isn't it? 11 11s are 121, which gives a remainder of 4. So by using this trial and error method, I can calculate the value of x as 5. So this is how you can implement Fermat's theorem to find out or solve such problems. Okay. So hopefully you understood, and there are many other problems on the internet for you to practice in this particular manner. Let's talk about Euler's theorem. But before you go to the Euler's theorem, we need to discuss about Euler's totient function first. So what is the Euler totient function? It is written as psi of n, which is a fundamental function in number theory that counts the number of integers from 1 to n that are co-prime to n. That means they don't have any other common factors other than n and 1. By convention, psi of 1 is equal to 1. Now, if you want to understand how do you calculate this and what it actually means, I have brought some examples for you. For a given positive integer n, psi of n is the count of numbers k such that 1 less than or equal to k less than or equal to n and GCD of k comma n is equal to 1. That means if I want to ask you about let us say psi of 10, you need to find out all the numbers from 1 to 10 that do not share any common factors with 10. So 1 does not share anything, 2 shares because 2 5s are 10, 3 does not share, isn't it? 4, 2 is there, 5, 2 is there, 6, 2 is there, 7 does not have any common factors with 10, 8 does have a common factor, 9 does not have any common factor, 10 has a common factor of 1, isn't it? So if you can note this down, these are the values that belong to the set of psi of n, and the number of values is 4. Okay, so if n, you can calculate it directly. If n is a prime number, then psi of p is equal to p minus 1. You can directly calculate. If I ask you what is psi of 7, 7 is a prime number, isn't it? Then you can simply write 7 minus 1 is equal to 6, which means there are 6 numbers from 1 to 7 which are co-prime to 7. If n is a power of a prime number, that means if n is equal to 9, and I can write this number as a power of the prime number t square, I have to do it in this particular manner. 9 into 1 minus 1 by 3, which gives me 9 into 2 by 3, which is 6. So numbers that are co-prime to 9 are 1, 2, 4, 5, 7, 8, a total of 6. And if n can be written as a prime factorization, which we did earlier, if n can be written as a prime factorization method, then you have to use the same function. That means if I want to find out psi of 12, n is equal to 12, which can be written in the form of prime factors as 2 square into 3 power 1. I have to write down as 12 into 1 minus 1 by 2, which is 1 by 2, into 1 minus 1 by 3, the power of 3 here. So it is 2 by 3. If I do these calculations well, I get it as 4. So what are the numbers that are co-prime to 12? It is number, there are a total of 4, and the numbers are 1, 5, 7, and 11. This is how you found out what can be done. This is how you calculate the psi of n value for any given n. If it is prime, it is direct. If any number, you have to break it down into prime factors and then use this particular function to find it out. Okay. Now let us talk about, okay, before we go, let us look at more examples. As I told you, for a prime number, psi of p is equal to p minus 1, and if prime numbers p and q with p not equal to q, then n is equal to pq. This is another good example which we will be using in our further lectures. So if I want to find out psi of 21, which is not a prime number, and I can write it down as a product of two prime numbers, 3 and 7. So in that case, as I said, p not equal to q, isn't it? So 3 and 7 are different. So psi of 21 can be written as psi of 3 and psi of 7. This is a prime number, this is a prime number. So 3 minus 1 into 7 minus 1, which is 2 into 6 is equal to 12. So psi of 21 is equal to 12. That means there are 12 numbers between 1 and 21 that are co-prime to 21. You can see these are all the integers, 12 integers. Similarly, if I want you to find out about psi of 35, I can break it down into 5 into 7, which are both prime numbers. Once again, I can write them as 5 minus 1 and 7 minus 1, which gives me 4 into 6 is equal to 24. These are all the 24 integers. If I ask you to find out psi of 77, then if you can write down 77 as multiple of two prime numbers, 7 and 11, 7 minus 1 into 11 minus 1, which is 6 into 10 gives me 60. There are 60 numbers between 1 and 277 that are co-prime to 77. This is how you find out the Euler's Totient function denoted in this particular manner. Let us talk about the Euler's theorem. So Euler's theorem, which is a generalization of Fermat's theorem, and it states that for any positive integer n that is relatively prime to an integer a, GCD of a and n is equal to 1. That means in this case, if there are two prime numbers, both of them, if there are positive integer n that is relatively prime to an integer a, then you can write down as a to the power of psi of n is always congruent to 1 mod n. Please remember that this is a generalization of the Fermat's little theorem that we studied earlier, where psi of n is the Euler's Totient function, which counts the number of integers from 1 to n that are co-prime to n. There are some key conditions for us to apply the Euler's theorem. N must always be a positive integer, and a must be an integer such that GCD of A comma N is equal to 1, such that A and N are co-prime. So both A and N must not have any other common integers or common divisors. The modulo operation, this is the modulo operation, ensures that when A to the power of psi of N is divided by N, the remainder is always 1. This Euler's theorem is widely applicable in cryptography concepts, which includes RSA algorithm, modular exponentiation optimization, number theory, and group theory. So let us do some examples to understand Euler's theorem better. You can see here, verify and prove Euler's theorem for A is equal to 3 and N is equal to 10. So A is equal to 3 and N is equal to 10. You have to understand that both of them, the GCD of 3 comma 10 should be 1. Only then I can apply Euler's theorem. In this case, first I need to find out, what is Euler's theorem? Do you remember? Please tell me once. What is Euler's theorem? So for you guys, I'm showing it again. A power psi of N is congruent to 1 mod N. So A, I'm writing it down. A power psi of N is congruent to 1 mod N. Here what is N is 10, isn't it? So psi of 10 I need to calculate. What is psi of 10? I told you psi of 10 can be calculated as, if I can break down 10 into 2 into 5, both are prime numbers. So this can be written as psi of 2 into psi of 5, which is nothing but 2 minus 1 into 5 minus 1, which is nothing but 4. So I got the value of psi of 10. So now I have to prove that 3, which is a value, to the power of psi of N is congruent to 1 mod 10. Now I calculated psi of N value. What is psi of N value? 4. So 3 power 4 should be congruent to 1 mod 10. 1 mod 10. Isn't it? So what is 3 to the power of 4? 9 9s, 81. So 81 mod 10 gives me the answer as 1. So Euler's theorem is proved. Let me try it for the other one also. What is A is equal to 7 and N is equal to 20. Once again, you have to check the value for this to ensure. So GCD of 7 comma 20 is equal to 1 or not. Yes, it is 1. They do not have any other integers that are a common factor. So I can implement it here. Now, for this, I need to find out what is psi of 20. Now, psi of 20 cannot be written as a product of two prime numbers, isn't it? So that is the case. I can do the prime factorization method, which I can write down as 2 into 2 into 5, which is equals to 2 square into 5. In this case, how do I find the psi of N? As I told you, 20 into, well, this is 2, isn't it? 1 minus 1 by 2 into 1 minus 1 by 5. This is how you write it down, which equals to 20 into 1 by 2 into 4 by 5. So 2 2's 5 hours, which gives me the answer as 8 if you solve this. So which means psi of 20 is equal to 8, isn't it? Now, once I have the value of psi of 20, I can simply write this down as 7 power psi of N is congruent to 1 mod 20. I need to check it now, which implies 7 power 8. I need to calculate the value. So let me break it down into pieces just like we did earlier. 7 square is equal to 49. So 49 mod 20 will be how much? 9, because 22 are 40. And 7 power 4 gives me 9 into 9. 7 square into 7 square mod 20, which is 81. Once again, it gives me the answer as 1. So if you need 7 power 8, I can simply write 7 power 8 is equal to 7 power 4 into 7 power 4, which is nothing but 1. So this proves that 7 power 8 is congruent to 1 mod 20. Once again, I am able to prove the Euler's theorem. So there is another application here. It asks where you can use the Euler's theorem to find out the remainder. So it is asking me, what is the remainder when 7 power 20 is divided by 12? So you have to find out whether the GCD of 7 and 12 is equal to 1 or not. If so, then you can employ the Euler's theorem. So what do you do? You need to find out the psi of 12 here. So psi of 12 is 2 square 4 into 3, isn't it? So once again, I can find out 12 into 1 minus 1 by 2 into 1 minus 1 by 3, which tells me 12 into half into 2 by 3. So which equals 4. This is the way how do you calculate. You can, if you know it, you can directly do these psi of n values for smaller numbers also. 4. So in that case, 7 power 4 should be equal to 1 mod 12. But I need to find out what is 7 power 20. So how do we write it? 7 power 4. 7 power 20 can be written as 7 power 4 mod 5 to the power of 5, which implies 1 to the power of 5 mod 12. So the remainder, when I get 7 power 12, when I do 7 power 20 mod 12 is equal to 1. This is the remainder. This is the answer. There is one more problem which we can perform here. Okay, so let me take another one. Solve 7 power 133 in Z26. Z26 is nothing but mod 26. This is the finite field which belongs to mod 26, isn't it? Now let us solve this. Once again, you have to check whether the GCD of 7 comma 26 is 1 or not. So this is 1, isn't it? Now in that case, what you need to do is you need to find out psi of 26. What is psi of 26? If you can break down 26 as a multiplication of 2 primes, 2 into 13, I can write this down, isn't it? 2 is a prime number, 13 is a prime number. 26. In that case, 2 minus 1, 13 minus 1, which equals how much? Tell me. 12. This I wrote it as psi of n is equal to where n is equal to p into q, psi of p into psi of q. That is 2 minus 1 into 13 minus 1, which gives me 12. So if there is a case, 7 power 12 should be congruent to 1 mod 26. Now it's all comes down to how do you write the 133. So which I can write down as 7 power 12. 12 tens are 120. 12 11s are 132. So 11 into 7, I can write this is equals to 1, so which gives me with 7. So 7 power 133 mod 26 gives me a remainder of 7. This is congruent to 7. So this is your final answer. These are some of the problems, and I got these problems from the textbook, so I wanted to solve these as well for you to get more practice out of these things. Okay, so let me just show you this. So show by calculation that Euler's theorem is true for n is equal to 10 and for all a less than n. Now what are the possible a values here? A can take all the values from 1, 2, 3, 4, 5, 6, 7, 8 and 9, isn't it? Now for all these values, if you find out what are all the values that are relatively prime with 10, I told you which is nothing but psi of 10, which is equal to 4. So what are all those values? 1, 3, 7, 9. So psi of 10 is going to give me these values. If I can prove for all these values that Euler's theorem is holding good, then my job is solved. So let me do it for 1. If I take it for 1, what I need to do is, because psi of 10 is equal to 4, I need to prove that a to the power of 4 is always congruent to 1 mod 10. The possible a values are 1, 3, 7, 9. So I am not going to 1 power 4 is always equal to 1, isn't it? So what about 3 power 4? 3 power 4 gives me the value what? 81, isn't it? So 81 mod 10 equal to 1. What is 7 power 4? If you do the calculation, 7 power 4 is equal to 2401 mod 10. Once again, it gives me the value as 1. What about 9 power 4? 9 power 4's value is 6561 mod 10. Once again, it gives the remainder as 1. So for all these values, I can prove that Euler's theorem is true, because my possible values of a are 1, 3, 7, 9, because only these 4 numbers 1, 3, 7, 9 are having are relatively prime to 10. Only then we can employ the Euler's theorem. So let me go to the next one, which is the Euler's theorem to find out the values of number between 0 and 9 such that it is congruent to 9 power 101 modulo 10. So it is asking me to find out, I need to check once before I do this, GCD of 9 comma 10 is equal to 1 or not. Yes, it is true. So I need to find out psi of 10. Psi of 10 is 4. We already did this calculation earlier. So in that case, what I need to do is 9 power 4 is equal to 1 mod 10. This is this for a fact, I know this. Now, how do I convert this? I can simply write 9 to the power of 4 to the power of 25 into 9. In that case, which I can get as 1 into 9, which gives me the answer as 9. So the value of, to find the number A is equal to 9 here. Similarly, this is also another simple one, which we can write down as a congruent to x power 61 congruent. So I need to solve this as x power 61 is congruent to 7 mod 15, isn't it? Now I know that 7 and 15 I have to check. Okay, fine. They both are relatively prime or not. Then what is psi of 15? I can write 15 as 3 into 5. So which brings me to the equation of psi of 3 into psi of 5, which is nothing but 2 into 4, which gives me the answer as 8. Now I know that if it is relative prime, x power 8 is congruent to 1 mod 15, isn't it? X power 8 is congruent to 1 mod 15. Now in that case, what I need to do is I need to break down the 61. So x power 8 whole power 7, which is 56, into x power 5 is equal to or is congruent to 7 mod 15. Now once I get this equation, which breaks down or which comes to x power 5 is congruent to 7 mod 15. What is the value of x? Now I have to take the once again trial and error method starting from 1. So once I start doing this, I need to try 1, 2, 3, 4, 5, 6, 7. Now at a stage, what you will be getting is x is equal to, let us say that 5 power 5, 6 power 5, 7. If you take 7 power 5, you get 16,807. I did these calculations earlier, so I'm directly giving you the answer, which mod 15 will give you a remainder of 7. So once you have this particular equation, you have to solve this equation using trial and error method. And you simply start from 1, 2, 3, 4, 5, 6, 7, 8, and so on till the mod value, and then you will come across the answer. So these are some of the problems that are done using Euler's theorem. Okay, so hopefully you understood the Fermat's little theorem and Euler's theorem and how we can implement them to solve these problems on number theory. So my next video, I will try to cover some more numerical problems using these two theorems. Till then, good luck and take care.